some of the things you might consider when evaluating them for your needs. A plate press is suitable for certain municipal applications such as waterworks residuals or industrial applications depending on the needs and sludge properties of the facility and where batch operation is acceptable. A plate press delivers the highest dryness of what we are discussing today. In municipal applications, dry solids can be up to 40%. Dryness of 90% or higher on some industrial applications is also possible, with a solids capture rate greater than 99% in most cases. Polymer and power usage is also low, and it is available in a variety of configurations, including a fully automated version. The plate press, also called a plate and frame filter press, is operated by utilizing a stack of plates that are compressed together. Slurry is pumped in between the plates and the chambers are gradually filled up and pressurized via a feed pump. The solids compress and form a cake in the chamber between the plates. As pressure rises, clean filtrate is pressed from the slurry and drains from the plate press. Sometimes the plates incorporate membranes that can be pressurized to apply additional pressure on the cake. When complete, the plates are then separated and the dry cake falls into a capture chute below the press. Once the process is complete, the filter plates are cleaned and the next batch can begin. The belt press is a mainstay in biosolids and residuals dewatering. They are flexible and easy to operate and provide high dryness in a variety of applications. Innovations in belt press technology are leading to even higher performance, and we are starting to see dryness closer to something like a centrifuge. They are typically available in a variety of sizes and configurations and can handle high flow rates. Many designs are able to be upgraded or expanded if future needs change the process. They use low polymer and power and are a reliable, time-tested dewatering method. The belt press dewatering process begins when flocculated sludge enters a distribution box and is spread over the width of a gravity deck that consists of a continuous porous belt. As the product moves down the belt, plows, also called chicanes, repeatedly split the flow and starts the process of releasing water from the product. The porous belt allows water to escape and drain into a collection pan below. The thickened product then moves into the pressure zone of the belt press and is squeezed between high-pressure rollers that gradually decrease in size. More advanced designs in the market will allow for adjustment of the wedge prior to the pressure section, as this will control the initial shear that the product sees. After pressure is applied, dry cake then exits the press and the belts are cleaned with a spray bar. The belt press is a very common method used by thousands of wastewater plants around the world. They continue to evolve, adding new performance features and capabilities. We'll talk more about some of these innovations in just a few minutes. A decanter centrifuge is the final dewatering method we'll talk about. Its design for dewatering operates generally the same as one for thickening, so we won't review that again. But there are some differences in how the machine is set up. The angle of the cone of the bowl, the feed zone, and the pond depth are typically set up differently, as the dryness requirements are different. A decanter centrifuge provides high cake dryness and can handle the highest amount of capacity per square foot of its compact footprint. Once the centrifuge is set up and optimized, it often runs with little to no operator intervention. It is a high-speed piece of rotating equipment, though, so requires periodic maintenance to address wear and tear. It also has higher power consumption than other types of dewatering equipment, such as a belt press. It is fully enclosed, which is helpful in reducing odor. You often see decanter centrifuges selected for medium to large wastewater treatment plants because the footprint required for other technologies would be much, much larger. Now let's walk through and compare the three technologies we talked about. Both the centrifuge and the plate press have a very high capacity per machine, but the compact nature of the decanter centrifuge gives it a very high capacity for its size. When it comes to dryness, the plate press delivers the highest dryness, but it must be run in batch operation, so is typically used in waterworks or industrial wastewater applications. As we mentioned before, the decanter centrifuge has the smallest footprint of the three technologies, but also requires more power and may have slightly higher maintenance because of the need to occasionally maintain high-speed bearings. In dewatering, the decanter centrifuge uses slightly more polymer than a belt press, but the belt press does require more wash water. A plate press can sometimes require more operator attention, but there are options that will automate the process, so this may not always be the case. And finally, because of the high-speed operations, the decanter centrifuge will produce more noise than other alternatives. Looking at several of these, as well as the cost to dispose of solids, will help you determine an overall cost of ownership as well. As with thickening, your individual situation and needs will help determine which of these priorities to focus on, and your manufacturer should partner with you to understand and provide options to address those needs appropriately.